So before I actually start talking about what I'm going to talk about, I wanted to add a quick postscript to JD's talk. His adaptation of Munki in a Box for the service desk environment is absolutely the kind of adaptation I was hoping and expecting to get out of Munki in a Box, because it's designed to be a reference implementation. It's not necessarily designed to be a production implementation. And so as part of that, I put up on the screen, there is a security tree, or a security branch of Munki in a Box that is actually designed for a more secure environment. It is not doing machine certificates yet. It is currently doing an SSL wrapper and HTTP basic auth. And so that's up in the security branch. This is what it is. It adds a couple of extra variables and a couple of extra settings that you're going to have to be responsible for. But it's there. So for those of you who don't know me, my name is Tom Bridge. I'm a partner at Technolutionary LLC in the Washington, D.C. area. We serve probably around 50 clients, around 500 Macs, from as far north as north of Baltimore all the way down to Springfield, Virginia, Loudoun County to the west, and the Eastern Shore to the east. So we have a pretty wide range. And consultants often tossed around as a dirty word, and I understand a lot of that concern. At our worst, we're a hacky programmer combined with a used car salesman. So, but at our best, we're open source contributors, we're hardworking, thoughtful IT admins with a pretty distributed portfolio. And we're more than oftentimes just the DevOps guys who are making the systems run. I also have to take responsibility for things like the phone system, as well as anything that plugs into a wall is often my fault. This presentation is here to help you understand a bit more about Munki's underpinnings and how it operates, how it exchanges information between client and server, how it can be hardened to protect your environment. Once upon a time when I was young and stupid last year, I wrote a piece of software called Munki in a Box. How many people have seen or run it? I mean, I guess we've all seen it now, so, but there's a fair number of you who've seen what I've been up to. And like some projects out there, it was ambitious in its goals. In my case, I wanted a standard Munki stack to deploy on the caching service mini that we often have at many of our clients. We're using server, yes, that server, in many places. So a local distribution node for our patch management system would be an excellent idea. But like many rookies out there, I had some bad ideas. Really bad ideas. Really, really bad ideas. Sorry. I released very insecure code. HTTP only by default was a bad idea. So was executing everything, at least in the initial versions up through 1.3, just requiring sudo and just being lazy and just saying, root, go do it. There were some loops in there that were potentially disastrous for your environment. And for that, I owe the software gods and the community an apology. I did dumb things. But I'm not sorry. On the other hand, we learn by doing and developing and producing updates and iterating code and responding to criticism. It's hard sometimes to look back on what you did because you didn't know then what you know now. And that can feel awkward and terrible and frustrating. We learn by doing and iterating and making it all better. You know, as Shakira told us in that song in Zootopia. Seriously though, thanks for that, Disney Animation Studios. And for Munki. I guess we'll give you credit for that one today. So the basic Munki interaction, the transaction where a client talks to a web server to retrieve a manifest, a catalog, and some packages, and then executes them, is designed to be done between trusted sources. Munki installs updates as root, as your super user in your environment. And at least prior to 10.11, root can do some pretty terrible things to your system. Root can still do pretty terrible things to your system. The damage is just constrained now to an area outside of the primary operating system. This is the exchange that we make with Munki. We give an application root privileges so that it can execute trusted tasks for our benefit. So let's talk a little bit about that trust. You know, with Munki, the launch daemons run hourly on a random interval. The launch daemon runs on the client directly. All of Munki is, of course, done on the client. You know, it says to the server, hey, do you have a manifest and a catalog? I'm looking for this manifest and this catalog. And the server responds with those files, like a standard HTTP transaction operates. And then the client does the compare, grabs the updates from the server, and runs the updates. So This is the kind of connection that Munki in a Box is written for. It's written for an HTTP transaction over a local network for machines that never leave their own network. It's meant for that 20-person company, all iMacs, all locked to the table, server locked up in the closet. Everybody goes home at night and hangs out with their family. Those really don't exist anymore, but that's what I wrote it for because it seemed like a good idea at the time. It's a really limited environment. Does anybody support an environment like this? A couple people here and there. Yeah, lucky is a good word. In this particular situation, how you handle your traffic is less important than good repository maintenance at that point. And so the talks that Elliot gave yesterday on how not to do bad things with auto-package is almost certainly your biggest worry. But a lot of us have transactions that look a lot more like this. Some clients connect over the LAN, while other clients, like laptops, roam freely and use the VPN to call home for updates. Seems like a good plan. But if you're not using SSL certificates in this particular case, you're subject to a man-in-the-middle attack. That's what you're worried about first. This is Malcolm. He's our man in the middle today. Malcolm is the unscrupulous sysadmin at Jim Thornton's coffee shop in downtown Calgary. And he's set up a network to watch for URL paths that look like Munki manifests and catalogs, so that he can hijack the traffic from those URLs and point them at his own properly structured but deeply malicious set of manifests and catalogs. Why can he do that? Well, he's got control of the router and he's a bit of a dick. If you're not encrypting the Munki transaction, you're going to run into Malcolm at some point. And that's not going to be a whole lot of fun because, again, Munki runs his root. You get a package that says, I want you to install Firefox, or Chromio, or MacKeeper. And suddenly, poof, you have that software because it's run as root, right? It's already got the permissions. You've already installed it with your admin password, blessed it, and said, go forth, do no harm. Except that they're really not bound by that. There's only so much harm you can prevent at that point. So the lesson here is SSL all the things. Installing a self-signed SSL certificate is probably the easiest way to do this. It's going to require a couple of changes in your environment. For example, if you're doing self-signed or if you're doing commercial signed, but maybe it's with a Komodo service, certificate that isn't as common, you may need to tell your clients, hey, trust this. This certificate is me. I care about you. So therefore, this certificate is halfway decent. It's also going to require you to alter your Munki repo URL using a defaults writer and other similar method for overriding your previous settings. In Munki in a Box, with the security branch, I'm cheating. I'm openly cheating. And I'm using the SSL certificate that's built into server.app. So when you set your host name up as part of that process, and when you go through that server setup, I'm using that cert. And while I'm rolling it out to clients, I'm essentially doing an OD bind. Not a full password protected bind, but essentially saying, that guy over there, he's halfway decent. Trust what he says. So I'm cheating. You can do this with a commercial SSL certificate for cheap. Or we can talk a little bit later about how to do this with Let's Encrypt and some other options there. Make sure you test this process cleanly and frequently before enacting it on your fleet. And you should probably have this enacted by how's 5 o'clock today? Does that sound good? We're not talking about a hugely difficult change in your environment. You need an SSL certificate on the web server that hosts your Munki repo. You need that cert to be trusted out. And you need to make a change in your repo. That is 2 packages and some scripts. And you can throw that in your existing repo and essentially say, update 4, thank you very much, have a nice day. And now you can turn off HTTP, or at least set the redirect to always redirect or point people at the right direction. Alternatively, if you're already installing a CA through your Munki environment, and the certificate that is on your web service is signed by that CA, that will also suffice. Then you don't need to add a trust profile to that process. There are other transaction types that I want to cover here today, and this slide is a good example of a final solution that you might face. You might want to have field-based clients out there checking in with your central repository. You might have gotten gutsy one night, and after a long day of planning and testing, and maybe a victory beer, push the button to encrypt your Munki transactions. You're safe now, right? You've got end-to-end encryption in place. It's great. You're safe. Wonderful. Nope. Malcolm again. Sure, this time he can't stand in your way and replace the packages with packages that he set up himself, packages like Chromio or Firefox, which kind of look right but aren't. And they might be creating a reverse shell back to Pyongyang, for example, and that would be, on a scale of 0 to bad, up there near bad. So your fleet is now safe, at least a little bit, but is your environment? Who here is rolling out in-house created apps that have automatic access or at least some automatic access to your own environment? I see some hands. How many people are rolling out custom configs, printers and things like that give you access to your internal resources? Lots of people. You're also probably going to be rolling out commercial software that carries with it license restrictions. For example, if you were rolling out Office, for example, and you are licensing a copy of Office, if someone were to connect to your Munki repo and say, "I'd like Office, please," it would deliver. Because you have no way, at least in this current situation, to say, "I am who I say I am supposed to be here." This is the equivalent of the guy who is in the back of the room who kind of looks like he doesn't belong at your conference, but maybe he's just hanging out. So it's never just apps that you're deploying. You're also deploying configuration management, state management, and you're going to have obligations to your organization to protect that information. So you don't want just anybody who trusts your certificate to read your packages directory. That would be bad. So don't just put up a fence, lock the gate. A totally open repository is a problem because it means anybody can root your repository of its delicious bits. Having an HTTP basic auth password at play adds a second layer of prevention to your first layer of SSL security. It's not enough just to secure your interactions so that your clients can trust the server. You have to keep the barbarians who will raid your software library for fun and vulnerabilities out of your environment. Doing this is straightforward, and it requires support of HTTP basic auth. We've all run into basic authentication along the way of our web travels. You visit a website, a sheet drops down, and you get to put in a user and a password. We've seen this, at least for me, since 1994 when I got the internet for the first time. It requires two changes to implement. Server-side changes to add the user list and password list, and a config change for your web server. And then it's also going to require a change on the Munki side. So this is the block that I'm using in Munki in a Box to alter the HTTP basic auth. And so essentially at that point you write a file to .htaccess, you add passwords to that file, and then you change the permissions on those particular files so that they can only be read by the web service, at least for the password file. HTTP basic auth in Munki is a lot simpler. Basically you say, default's right, managed installs, additional HTTP headers, and then add an array with the HTTP auth. In Munki you can see that we are creating that variable with base 64 operation there just to give you a long string, and that's just required by the technology. So your password is not the only way to do this. You can stack passwords to your heart's content in HTTP basic auth. You can have multiple usernames and passwords and the whole 9 yards, but once you have lost control of that password file, you have lost control of your server. Bad. Very, very bad. So, but the question becomes, why do we have passwords at all in this era of certificate-based authentication? With public key infrastructure, you should absolutely have good PKI and good certificates for your environment. So certificate-based authentication is no stranger to anybody who's worked in the Casper suite or Puppet. If you're using Puppet in your environment already, there are good tools to adapt your Puppet CA to use with your Munki repository. And we'll get to those links a little bit later. It will require more setup, though, if you don't already have a CA, but here's the basic gist. Your root certificate authority, created at the server end, will sign requests generated by your individual client machines. The client will need to trust the cert CA doing the signing, so you're going to need to deploy a trust profile to handle that, or a package with a script to trust the CA. This is not an onerous process, but it is required, and you'll need something capable of handling that process for you. This is often why Puppet makes a lot of sense in terms of giving you the resources for free in this case. But the real strength of your environment in a cert CA situation is the ability to revoke certificates. Got a machine that tests positive for malware? Revoke their certificate. They've lost your access to your repo. Employee gets hired by another organization while they're on a business trip? Revoke that certificate. They won't get your next updates. Stolen machine? Revoke. Decrypted their own machine? Definitely revoke. Bad day? revoke. That's an option if you want to go that route. So cert-based auth in Munki clients just requires 3 things. It needs to know where the CA certificate is, it needs to know where the client certificate is, and it needs to know where the client key is. And those are marked, in this particular case, this is based off of the example that's in the Munki wiki. And so if you can arrange for those certificates to be dropped pleasantly in the certs folder inside /library/managed installs, or if you're really, really concerned, or you want to use a common certificate for a group instead of an individual user, you can throw those in the /var/root/library/preferences/managed installs directory instead, and then just update the path there. That is also true if you were doing just straight basic auth. If you don't want the user to have access to the credential that is used for signing into basic auth applications, throw that in the /var/root/library/preferences/managed installs folder in that version of the plist. So there's some good news here amid the fray. Despite our friend Malcolm hanging out in the middle, sometimes with access to your repo, or worse, access to your clients, or worse still, with a signed blue coat certificate like a good nation-state actor, there are some shortcuts you might be able to take. And if you've never done this before, there are a couple of great guides on how this is all going to go for you. And I'll make sure that those get included in the show notes here for today's event. And they're in the links at the very, very end. Don't just rely on the shortcut, though. It's important to understand what you're doing as part of that process. And if I've learned anything from developing Munki in a box and adding more features and functions to it, it's the more that I actually learn about the environment, the closer I get to mastery of it. I am by no means a Munki master. I am out here just spending my day in it and diving in hands first. So don't necessarily rely on the shortcuts. It's not necessarily going to save you time in the long run until you've started to iterate this out so many times you could do it in your sleep. But the other thing is that it's important is that everything that we've talked about today is about stopping the transactional security flaw. And that's not the only place where your Munki environment can be a problem for you. And I know Elliot talked at length yesterday, so I'm not going to repeat the how not to do bad things with auto package talk, because it was excellent and I strongly recommend it. That there are a lot of things that he mentions that I think are very, very important to reiterate. And they come down to be very, very careful what you allow in your Munki repository, especially if you're going to update that through auto package. And especially have some human checks upon your update process, whereby you can review the code, make sure that you're not going to hose your own machine. But it's really, really important that you test your environment. And having test sections of your fleet or of your environment that you can clearly tell if they've had problems. You need to spend your focus there. You may not watch every commit. And I get that. We all have jobs to do. We all have meetings to sit in. But you have to trust that at least you're working with good actors. I've got a set of about 6 auto package repos that I automatically download because I trust those people. And I trust them that they take their job very seriously. And I think that that's very, very important for us to talk about. So IT operations isn't going to the moon. But in many cases, the amount of systems uplift that we do is a huge amount of work. What we do is keep our clients and our employers above the fray. There will always be actors you cannot control and attacks you cannot defer. But having your environment set such that you can survive an all-out attack on your client process, or at least to the best of your ability, is going to be key in terms of regaining your users' trust in the event of disaster. And so that's really, really important. So we do these things not because they're easy, but because they are hard. And because money is nice, and without security, money's a lot harder to get. So I put together a whole bunch of resources up here on how to go through these processes. Lucas Hall has a really excellent implementation of Docker with Munki with certificate authorities involved, and that's really excellent. Victor has put together an automated process, or at least a process that I'm going to be branching Munki in a Box toward, which is using the Go-based Caddy server for HTTP, which will allow us to finally step this away entirely from OS X server, as well as using Let's Encrypt to create the CA and go through the process of certificate renewal and making sure that you get clear notifications when certificates are about to expire. Nick McSpadden has securely bootstrapping Munki using Puppet certificates, and that is the Puppet talk that I mentioned before, and also using Munki with Puppet and SSL client certificates. Both of those are twists on Docker, and so they are good ways to get Docker expertise put together. And lastly, but not leastly, the Munki wiki for using Munki with SSL client certificates is there. So with that, I'm going to open up the floor to questions and maybe some conversation about securing your Munki environment. Everybody here using certs already? A couple hands here and there, which is good. Thank you. Clay.
Is it on? Hey, there it goes. If you're using the Puppet CA, most people have those set to auto-sign. How do you manage control and access to the CA? I'm asking for a friend.
Right, that's a marvelous question. And I'm sure that there are other folks in the room who are actually doing that more frequently than I am, who might shed some light on that side of things. Graham, have you guys turned on auto-signing or off? Or are you guys not using that right now? I don't have Puppet yet. Okay. My guess would be making sure that the signature process is only available from a network you trust is a good place to start.
So the person is not supposed to speak.
Clay, do you want to comment on that? Should Alice just speak?
If the question is, should Alice just speak, the answer is always no. The JSS has an API. If you use the enroll package, that's, a bundle package, and, so very secure. You can still have that as your source of truth that Puppet looks at to approve the certificate signing requests. Pretty much what the Puppet CA can do when it sees a client check in is it can run an arbitrary script at a path that you set in the Puppet server's configuration, that when it goes and checks over a API, it can say yes or no. One of my best days in my working career recently was changing that to sign based on SAL. And I used the API from SAL in imaging to seed the serial number, essentially, and then Puppet knows that it can sign that cert.
So at that point, you're actually doing a hardware check as well as a...
Yes.
Cool.
So at imaging, the serial number gets sent to SAL. Puppet checks against SAL, sees that it exists, and says, OK, I'll sign it when it goes to check in for Munki.
Cool. Halfway decent answer? Okay. Other questions? Mr. Keeley, you're part of the reason I actually thought about this talk.
So I'm concerned about Malcolm in the Middle getting control of my Munki repo. So what if he gets access to write to my Munki repo? How can I guard against that? That seems like taking control of all my computers. How can
you step aside from that process?
How can I set up a secure Munki repo that way?
Right. Well, one of the easy answers there is a solid source control system, and working against a solid source control system, you can commit to the web service that then issues out your manifests and your packages. So if you're requiring 2FA to commit to your repo, at that point you're at least guarded a little bit against what's going on there.
Just turn off all your computers, man.
I don't think he's being that paranoid. I think that's we got to think about these kind of vectors for our systems. If you get control of the machine that runs the environment, congratulations, you're Palantir. And you're vulnerable to a red team at that point.
That concern plagues everything, of course.
Of course. I was going to say, yeah. But that one in particular is a nasty variant. Is that a good answer, Sam?
Yeah, if we could turn off the computers, my job would be easier.
Excellent. Other questions from the field? Comments? Did I do all right? Alistair.
Yeah, only one thing. You had a slide with the 3 keys for using the client certs. You really only need to say use client certs true. And then if they're at these default paths. And also the certs folder is only readable by root. So you do have some protections in that respect that you don't need to necessarily shove it deep into var root's home folder.
Okay.
And that's just like a simpler way. So if it removes a hurdle for people who are like, this is all just crazy to manage, it really is only the one key. If you take the client cert and the client key, you can just append the key to the end of the cert.
Okay.
And if it's one file called client.pem, that's the default that Munki looks for. And it'll look for a file called ca.pem as well.
Okay. Thank you. I will update these slides and reissue. But so thank you, everybody. So if you want to find me on social media, I'm on T-Bridge pretty much everywhere. We just released another episode of the Mac Admins podcast with Rich Troughton and Harold Monahart on stuff from WWDC, so find that there. And the slides will be up at cannonball.tombridge.com.